In this section, we will discuss milling tools. There are two types of milling tools. First, tools that are equipped with inserts, and second, tools that do not have inserts, called solid tools. First, I will talk about solid tools or milling tools that do not have inserts. The most common solid milling tool is the square end mill, or simply just an end mill, as you can see here. Unfortunately, milling tools are not standardized like turning tools, and each tool manufacturer has its own coding standard. Therefore, I will not talk about milling tool codes. Instead, I will describe their use and the technical issues related to them. Here, you can see an end mill where the flute and shank length are shown. Generally, end mills are capable of cutting a depth equal to their flute length. This cutter has 4 cutting edges, or 4 flutes. The number of cutting edges is an important feature that affects the cutter's durability against wear. Usually, end mills used for hardened steel have many cutting edges, which helps distribute eventual wear among the edges. However, when there are many cutting edges, there is less room for chips, and the cutting forces are usually higher. Therefore, for roughing operations, it is better to use end mills with 2, 3, or 4 cutting edges, especially when there are issues with chip evacuation. For example, when making a slot or milling materials like aluminum, which produce longer chips, you should use 2 or 3 flute end mills. On the other hand, when milling abrasive materials like hardened steel, you should use end mills with more flutes, such as 6 or 8, so the wear is distributed among the cutting edges. On the right, you can see an end mill with a gold-colored coating. The grooves on this end mill help minimize vibration but leave a rough surface finish. These types of end mills, also called hog end mills, are mainly used for roughing. Some end mills have the capability of plunging, which means they can cut in the direction of the tool's axis. On the left, you can see a tool with 3 cutting edges, or flutes, that can plunge because one of the cutting edges passes through its center. On the other hand, the tool on the right cannot plunge because none of the cutting edges pass through its center. Different methods can be used to fix an end mill inside a holder. Here, a collet is used to grab the end mill from its shank. Collets are interchangeable, and different sizes of collets can be used with a holder. This gives flexibility in using the same holder for different sizes of end mill shanks. However, collets are not the best way to hold an end mill when forces are high or when low runout is required. Collets are a flexure structure that, when pressed by a collet nut onto the holder surface, grab the end mill. Usually, collets can hold shanks within a range. For example, here you have an ER collet, ER16, which represents the general size of the collet, and the range of 2 to 3 millimeters represents the shank diameters this collet can hold. There are other types of end mill shanks called Weldon notch shanks, which have a notch on their shank. In this case, a holder with a side clamp or bolt is used to clamp the shank of the end mill from the side. These types of holders provide a very strong grip and can withstand high cutting forces. However, compared to the collet system, the downside is that in the Weldon system, the holder shank hole must match the diameter of the end mill shank. In contrast, collet systems allow a range of shank diameters to be clamped. There are other holding methods, which I will discuss in a separate section. To conclude, square end mills are mainly used to make steps, slots, or flatten small areas. Generally, they are used in areas where there is a large depth of cut compared to the area size. At this point, I want to talk about up and down milling. In down milling, also called climb milling, the chip thickness at the start of the cut, when the cutting edge engages with the workpiece, is larger compared to the end of the cut. In contrast, in up milling, the cutting edge engages with the workpiece at low chip thickness, which increases toward the end of the cut. This applies to peripheral milling. Generally, down milling is preferred whenever the fixture, workpiece configuration, and machine allow it. However, down milling requires a machine equipped with backlash elimination mechanisms. As a rule of thumb, down milling is used in CNC machines because they have ball screws that eliminate backlash, while up milling is used in manual machines. Some people may not know what backlash or runout is, so before moving forward, I want to explain them. Backlash or play refers to the clearance or loss of motion in a machine caused by gaps between different parts. For example, if a CNC machine moves in the positive X direction and then the program changes its direction, the machine usually loses a couple of microns, resulting in movement short of the commanded value. Tool runout occurs when the tool's axis is not aligned with the machine's main axis, usually the Z axis. This can be caused by a faulty spindle, holder, collet, or a combination of these factors. Generally, a runout of up to 15 microns does not significantly affect tool life, but it might affect the quality and tolerance of machined parts. Another type of end mill is called a ball nose or corner radius end mill, which is very similar to a square end mill. The only difference is the fillet at the tip of the tool. This fillet makes the tool stronger and more reliable in roughing applications. It can also be used to create a corner fillet equal to the tool's corner radius. Ball nose end mills have a completely round tip and are mainly used to create anatomical surfaces. Industries like mold making, prototyping, and the dental industry are the main users of ball nose end mills. Slitting cutters can be used to make long and narrow slots or even for cutting off operations. While there are solid slitting cutters, some use interchangeable carbide inserts. There are also some less common tools, such as lollipop tools, which are used to cut undercuts and taper tools. Most of the time, you will use square, corner radius, or ball nose end mills, as other types of cutters are less common. Would you like me to generate a visual diagram or slide presentation based on this content?